Yeah, good morning, class. How you guys doing? And it's really unfortunate that I cannot be with you guys physically, but to ensure that you guys are not missing out on today's class, I decided to put a little something for you guys in this video, and I hope you can relate with it. So I hope you've gotten over the fact that I'm not in class and this is video. So it's not an entertainment, it's not a toy, it's a medium for us to communicate. So get over it as soon as possible because I'm going straight into the class. I think you're okay now. Yeah, let's go to this point. Remember last class when I was teaching you guys about the cellular response to foreign agents, to how diseases arise when the body is not able, that disease only arise when the body is not able to cope with the pressure of stimulus. And so that is the point I want to take you guys from. And so while you are watching this video, it's better if you open the Robbins and Cochrane pathology basis of diseases that we've been using. You open it by the side and go to the page where we stopped the last time. I'll quickly go through it and I'll discuss it, and I'll move to the next issue that I want to talk about today. So we started with the normal cells. And we said when things are okay, when things are going normally, the body's mechanisms are able to maintain the dynamics in the cell through a process called homeostasis. There are processes that the cell needs to ensure that functions are maintained in the manner that they ought to be. That is homeostasis. And but two things can happen when there is an external intervention. For instance, when there is stress, like I said, the cell is asked to do more than normal capacity. That is the stress. And in response, especially if the stress is short-lived, is adaptation. The cell attempts to get to push itself much further. That is adaptation. And but if the stimulus is very injurious, for instance, I use the example of excessive exposure to heat, that if it is too much, if you put your hand on a bouncing flame for 30 seconds or less, you will see some damages, but they won't be severe as if you are thrown in the middle of a burning flame for a very long period. So if the stimulus is injurious, it can lead to cell injury. Furthermore, if the stress is persistent, is long, and the cell is unable to overcome it as soon as possible, adaptation the cell may fail to adapt, and cell injuries can also arise. Even when there is cell injury, depending on the nature of the injury, if it's mild or transient, it becomes reversible. But if the cell injury is severe and progressive, that is really much, and it continues to escalate and progress, then irreversible injury can arise. And depending on if once an injury becomes irreversible, the tissue or cell affected are no longer able to perform their functions, and they are no longer under the process of homeostasis, so the body needs to get rid of them. And any of the two processes known as necrosis and apoptosis can be activated, and these two processes will lead to cell death. I said necrosis can be likened to is when the body cell's immune system, the organism's immune system, are tagging individual cells for destruction, while apoptosis is like suicide. I said within individual cells there are components that would kill and destroy individual cells. So that is how apoptosis sets in. And we mentioned different adaptations when there is how the cell tries to adapt. Those are the ones that are hypertrophy, hyperplasia, metaplasia, and the like. So I'd like to quickly describe them, because that was where we actually had to leave the class abruptly last time. So adaptations are reversible changes in the size, number, phenotype, metabolic activity, or functions of cells in response to changes in their environment. And there are distinct forms that they can appear as. So the first one is that I will mention this time is hypertrophy. So by definition, hypertrophy is the increase in size of the cells that are as a result of that results in an increase in the size of the affected organ. So in hypertrophy, the organ is increased, the size of the organ is increased, and the reason for the increase in size is the individual cells that are making up the organs are increasing in size. I use the example of if the normal cellular diameter is 10 nanometer, But in hypertrophy, they are stretched from 10 nanometer to, let's say, 25 nanometer. When you have 10 cells like that, the size of the individual cells has increased in that proportion, that the size of the organ itself will further increase. So that is what we call hypertrophy. And there are different mechanisms by which hypertrophy arises. And hypertrophy is a result of increased production of cellular proteins. And so when individual cells produce more proteins than normal, that is how hypertrophy increases. And the textbook contains lots of explanations about the mechanisms, which I will ask you to really read. And to ensure that you are reading it, make sure summarize the mechanisms in a short note and send it to me via this email address. I want you to send it immediately before 11 a.m. today. Okay, if you don't send it, you have missed mark for that. So the next example, the next mechanism is hyperplasia. The next cellular adaptation method is hyperplasia. Unlike hypertrophy, hyperplasia is defined as an increase in the number of cells in an organ or tissues in response to a stimulus. So the size of the organ is increased, not because of the increase in the size of individual cells, but because of the increase in the total number of cells. If an organ has 25,000 cells, but it is now having 75,000 cells, and you know that the size of that organ is going to increase. And interestingly though, while hyperplasia and hypertrophy are distinct processes, they frequently occur together and may be triggered by the same external stimulus. However, hyperplasia can only take place if the tissue contains cells capable of dividing. So which is really a key difference between hyperplasia and hypertrophy. While they can occur together, it is very worthy to note that only cells that are dividing are the ones that undergo hyperplasia. So while hypertrophy refers to the increase in the size of an organ or tissue as a result of increase in the size of individual cells, hyperplasia is defined as an increase in the number of cells in an organ or tissues in response to a stimulus. Basically, what we are trying to say is that when an organ increases due to hypertrophy, is due to the fact that the individual cells in the organs are increasing in size. But when an organ or tissue increases in hyperplasia, it is due to the increase in the number of individual cells. For instance, let's say a tissue is made up of like 10,000 cells, and they now increase to, let's say, 20,000 cells. You know, more space will be required to accommodate this additional 10,000 cells. And that is how, and because more space is required, the organ will now increase in size. So that is how hyperplasia arises. And it's worthy to note that hyperplasia and hypertrophy can occur. The same stimulus can activate both hypertrophy and hyperplasia. So we can see them happening concurrently, but on one condition: hyperplasia only happens in dividing cells, which means if a cell is not dividing, there will be no way for the number of that cells to increase, and which means the increment can only be attributable to hypertrophy. So that is a key take-home point for you to understand. Identifying hypertrophy and hyperplasia, or even ordinary hyperplasia, is indicative of a dividing cell, and this factor cannot be identified in non-dividing cells. So I want you to do something. Write 3 dividing cells and 3 non-dividing cells, and endeavor that you are not writing the same thing as others that are written before. So if I were you, I would do my own on time, so that others will not write what you have in mind to write. So that goes for it. And there is something that is called physiologic hyperplasia. Physiologic hyperplasia is attributable to the action of hormones or growth factors in several circumstances, when there is a need to increase functional capacity of hormone-sensitive organs, when there is need for compensatory increase after damage or resection. So what this point is essentially saying is that hyperplasia, which is increase in the number of cells, can occur. For instance, let's say there is a damage to a particular tissue. We will need more of that tissue. We will need more cells to occupy the vacuum that has been created to the exit of the cells or tissues that were occupying that place. So the number of cells in that area would increase. So that is physiologic hyperplasia. Physiology simply means it's a normal process. Okay, hyperplasia is not always, is not usual, is not all the time. When we see hyperplasia, that is in the negative instance. So sometimes it is a normal cellular response to injury, and so the cell trying to make up for a vacuum that has been created as a normal response. And there could be pathologic hyperplasia. And most forms of pathologic hyperplasia are caused by excessive or inappropriate actions of hormones or growth factors acting on target cells. Okay, and there are, when an hormone is present is in abnormally high quantity. Like I said, everything in the human system is regulated. Everything in the body is regulated. There is homeostasis in every chamber, in every process, in every cell. But let's say the body, the normal volume of an hormone is 10 mils. But due to the fact that there is something that is wrong with that part of the body, with the tissue that is producing that hormone, instead of having 10 mils, we are now having 100 mils. And hormones will act on a particular target. So when there are a large amount of hormones, the number of the target cells would increase in number, and that is how pathologic hyperplasia arises. And there are lots of examples there. One of them is in endometrial hyperplasia. It is a good example of an abnormal hormone-induced hyperplasia. What is happening there is that normally when after the menstrual period, there is a rapid burst of proliferative activity in the endometrium that is stimulated by pituitary hormone and ovarian estrogen. You know, every month women menstruate, and the layer of the endometrium is shed, so cells are destroyed, and this layer needs to be replaced. So hyperplasia normally happens to produce new cells to take over or to replace the ones that have been shed. And so this usually happens between 10 to 14 days before the end of the menstrual period. And but this form, but in some circumstances, the balancing, you know, hormones, different hormones are playing key roles at different stages of the female reproductive cycle. So, and this balance is really critical, because one will initiate the destruction, one will initiate the production of new cells, and another one would determine that, okay, this level of the cell that has proliferated, the newly produced cells, that the body has had enough of them, that the body should stop producing them. Everything is managed, is controlled by hormonal balance. So when this hormonal balance is affected, when this hormonal balance is altered, then problems arise, and that can lead to pathologic hyperplasia, and in this case it is called the endometrial hyperplasia. So you can use the name of the part of the body that is affected to actually denote or to describe the type of pathology that we are talking about. And not just a female system, that a female reproductive cycle that can be a target for pathologic hyperplasia. Cancer too. Hyperplasia is a critical component, is a critical feature of many cancers. And the reason is this: when cancers arise, what the underlying principle behind cancer is that the body has lost its ability to control cell production and cell multiplication. And I said normally there is a specific cellular turnover per tissue and per organ. Let's say a tissue that is expected to have like 10,000 cells. The way it maintains it is that each cell has its own lifespan. At the expiration of that cell's lifespan, a new cell would be produced to replace it, to maintain the cellular turnover, such that even when there is a need for growth, it is still controlled. okay, but the mechanism that maintains the cellular turnover and cell growth, these mechanisms have been lost in cancer. And so areas where you are expected to see 10,000 cells, because we are now having the mechanism that controls cell growth, these mechanisms have been lost. The number of cells will just be increasing in line in number, and the part of the body that this targeted tissue is located will now continue to increase in size. And this is why hyperplasia is a very significant characteristic of cancers. So there are lots of them, and apart from, we mentioned endometrial hyperplasia, we've mentioned hyperplasia in response to cancer. Hyperplasia is also a characteristic response to certain viral infections. A good example of such class of virus is the papilloma virus, which is responsible for skin warts. So, and papilloma virus is also indicated in cervical cancers too. So we see hyperplasia in response to altered hormonal balance, as evident in endometrial hyperplasia. We are seeing hyperplasia to indicated in cancer growth, in cancer development, and here also we are seeing hyperplasia as a characteristic response to viral infections. And there is sense in the role in hyperplasia due to attributable to viral infections, and this is because when viruses are in a cell, what they do is that they hijack the cellular machinery to ensure that cellular components are targeted at satisfying the viruses. Viruses will continue, they will rapidly multiply, invade new cells, because as they are multiplying they need new cells to invade, so new cells have to be produced, and that is how hyperplasia arises as a result of papilloma virus or other viruses that can actually activate this process. So I want you to also read up the mechanism of hyperplasia. But the summary is that hyperplasia is a result of growth factor driven proliferation of mature cells, and in some cases by increased output of new cells from tissue stem cells. So I need to read up that aspect and ensure that you understand it. Whatever you don't understand, just get across to me, and I'm going to shed more light. So the next feature, or the next manifestation, or the next adaptation that I will make mention of is atrophy. And in atrophy, don't forget the fact that we are looking at cells, okay, in response to stimuli. So what is happening in atrophy is there is a reduction in the size of an organ or tissue due to a decrease in cell size and number. Okay, the cell, tissues are made up of cells. Don't forget that. And there is in every tissue a well-defined number of cells are expected to be there, and the number of cells will determine the function of the cells and how much product that a particular cell is going to produce. Okay, and when in atrophy, in an area where you are expected to see 20 cells and you are now seeing 15 cells or 10 cells, there will be reduction. It will be smaller than normal, so that reduction is called atrophy. And atrophy can be due to the reduction in the number of cells or reduction in the size of cells. Okay, and like hyperplasia, there can be atrophy, can be physiologic, it can also be pathologic. Physiologic atrophy is common during normal development. Okay, and some embryonic structures such as in notochord and thyroglossal duct undergo atrophy during fetal development. The decrease in size of the uterus that occurs shortly after parturition is another form of physiologic atrophy. So what we're essentially saying there is that when during growth from childhood, when the baby is developing, some organs and tissues that the baby would not need would atrophize, as in they would reduce in size and eventually wither away. And If you study embryogenesis very, very well, you understand that both males and females arise from the same path, and there are tissues that are destined to become the male sex organ, and there are tissues that are destined to become the female sex organ, depending on the impulse, depending on the stimuli that are introduced, that are in action. What can happen is that if the stimulus is tending towards the baby becoming a boy, the tissues that are expected to lead to the development of the female sex organs would atrophize, they would reduce in size and eventually wither away. So that is how atrophy is playing out as a normal procedure. And even if you look at women too, during pregnancy, the uterus enlarges in size. The uterus becomes so big. So when you see a baby, a pregnant woman, you are seeing that big tummy, that is showing you how big the uterus can become. But immediately she delivers the baby, the uterus gradually goes back to its normal, to its size, to its previous size. That is also physiologic atrophy. So those two examples are really, really important, and there are lots of them in around us. So which is why I will encourage you to also find more examples of physiologic atrophy, and share whatever you can find with us in the comment section so that others can learn. And before you start writing anything, read around and look and see if somebody has written something, what you plan to write before, so that every one of us can gain from it. So examples of physiologic atrophy, so put them down. So we understand what physiologic atrophy is. So what about pathologic atrophy? Pathologic atrophy arises, it's due to two reasons. It can have two manifestations. For instance, it can be localized or it can be generalized. Okay, localized means only a specific part is affected, while generalized means it's all over everywhere. Okay, ensure that you understand these two terminologies. So pathologic atrophy can be localized or it can be generalized. But different factors can be responsible for pathologic atrophy. One of them is decreased workload, and it is called atrophy of disuse. Okay, let me give you an instance. Let's say you fracture one of your bones. Let's say you fracture your the bone in your arm. Okay, it gets fractured, so you go to the hospital, and so they've applied a plaster cast on it, or sometimes they would hang that fractured limb, that fractured limb, that they will suspend it so that it is kept still, it is not shaking, and it is immobilized, and the patient is asked to have bed rest for a long period of time. So because skeletal muscles are the ones that are holding on to these bones, and they've not the workload on that bone has reduced due to the injury, even though the patient is recuperating, even though the process is expected to make the patient better, but because the bone is not being put in use, the skeletal muscle will undergo atrophy. That means they will reduce in size, and well, by the time you compare it with the other limb that is being actively used, you will see that the size is quite obvious. So sometimes and that is why some people that had when people have severe fracture in the bones of the legs and they have to put cast for a long period of time, by the time they go back, by the time the cast is removed, the skeletal muscles would have reduced so much to the extent that the patient would actually have to start limping, even though the patient has completely recovered. So that condition is called atrophy of disuse, or atrophy due to decreased workload. Because the bone has not been used for long, the skeletal muscles will just reduce in size. So that is atrophy of disuse. Another one is loss of innervation. Okay, when normally skeletal muscles, they also undergo metabolism, and processes happen in them, they function too, and but they are largely dependent on the nerve supply. The nerve supply is the one that will bring in messages that this is what is happening and this is how your response should be. Is the information carrier, so they rely on it a lot for their function. But when there is damage to the nerves that serves the skeletal muscles, then the skeletal muscles can undergo atrophy. So accidents can lead to it. Anything that the diseases that target nerve endings can also arise in atrophy, the tissue being reduced in size. Also blood supply too. A gradual decrease in blood supply, which is known as ischemia, to a tissue will result in slowly developing arterial occlusive disease, can also result in atrophy of the tissue. Okay, and so as long as a tissue or organ is starved of blood supply, it doesn't have to be very sharp, like the blood supply being totally cut off. Even if it's gradual, then problems can arise, and the brain can undergo gradual atrophy. So if the blood supply to the brain is gradually being shut off because of the occlusion of blood vessels, such as the arteries that are serving the brain, it can lead to atrophy. Okay, and when this happens in the brain, it can be attributable to atherosclerosis, and it can also be called senile atrophy. It's not just the brain that this can happen, it can also affect other parts of the body, including the heart. Okay, and so we've seen atrophy due to decreased workload, which we call atrophy of disuse. We've explained atrophy due to loss of innervation, which is called denervation atrophy, and we've mentioned atrophy due to diminished blood supply. And even when nutrition is inadequate, when every tissue or organ requires glucose, requires energy sources. So when the tissue or organ is starved of nutrition, atrophy can arise. For instance, when profound protein calorie malnutrition, which is called marasmus, is associated with the skeletal muscle proteins as a source of energy after other reserves such as adipose stores have been depleted, and this can be the reason why you see some children that will be looking severely malnourished, because when the body does not have good nutrition, the body will strive to maintain balance by looking for nutrition elsewhere, and adipose tissues are a good sources of nutrition, of secondary nutrition for the body when external nutrition is not coming. And when these adipose storage have been greatly depleted, then skeletal proteins in the skeletal muscles, don't forget, muscles are also rich in proteins. So when the body is looking for energy sources, it has exhausted its adipose storage, and it will now go to skeletal muscle proteins. So, and when this is happening, don't forget, skeletal muscles are pulling stuff in position. They are the ones we need for locomotion. When this happens, then they can actually lead to atrophy, and gradual destruction of skeletal muscle proteins results in the reduction in the size of the skeletal muscles, which is what we are calling atrophy. Okay, and this condition will lead to muscle wasting, and the scientific term is called cachexia. Cachexia, C-A-C-H-E-X-I-A, cachexia. And this condition is seen in individuals with chronic inflammatory diseases and individuals that have cancer. And chronic inflammatory disease is due to the production of inflammatory cytokine tumor necrosis factor, and this leads to appetite suppression and lipid depression. So other things that can lead to atrophy also includes a loss of endocrine stimulation. We can also have pressure. When there is a huge pressure on the tissue and organ, it shrinks, it reduces in size, and several others. And so the mechanism of atrophy goes thus: it's as a result of decreased protein synthesis and increased protein degradation. Little protein is being produced and more proteins are being destroyed, are being broken down in cells. So if it were to be that as more proteins are being broken down, more proteins are being produced, we'll be able to achieve balance. Okay, I hope that's clear. If more proteins are being broken down and fewer proteins are being produced, the protein storage will be gradually depleted. So that is what is happening here. And the longer this imbalance persists, the more severe the symptoms. Okay, so body in homeostasis, there is balance between protein synthesis and protein degradation. But when more proteins are being degraded and less protein is being produced, then we have a problem, and that is the mechanism of atrophy. So I think the last point, the last change I would like to mention is a reversible one, and it's called metaplasia. Metaplasia is a reversible change. Okay, in metaplasia, what is happening is that one differentiated cell type is replaced by another cell type. Okay, don't forget we have different types of cells. So a specific type of cell, in an area where you are expected to see a specific type of cell, you are finding another type of cell there. That is what is called metaplasia. Okay, it often represents an adaptive response in which one cell type that is sensitive to a particular stress is replaced by another cell type that is better able to withstand the adverse environment. So we can describe this as the body's immune response, as a body's response to the environment. For instance, if the body knows that the normal cells in this area are very, very sensitive to temperature, that if the weather becomes slightly hot, the cells will be destroyed, and the tissue finds itself in a very hot weather, in a very hot environment, it can replace those temperature sensitive cells with cells that can withstand temperature. So even though the first set of cells are the normal cells I started to see in that area, but because of the nature of the environment, because of where the tissue has found itself, things have to be moved around, and just for the tissue to survive that external pressure, so that there are cells that can actually survive that condition are mobilized to that region. And we said this is reversible. The reason why this is reversible is that once the circumstances become normal, once homeostasis, once the tissue gets into its normal environment, the normal cells are brought back here. Now, if you look at all of these changes that I've described, you will see some connections that you can be able to figure out what can happen at one point or another. For instance, if we are seeing if the disease is just starting, there can be metaplasia. Okay, let's replace the cells that we have here temporarily and bring in new cells that can survive it. And normally, if the stimulus is removed, the regular cells will return. But if it does not return, then more interventions, more solutions. The cells, the body, the cell struggle, the tissue struggle to curtail whatever is happening, to, if it cannot remove it, to adapt to it. Is only when this pressure becomes too much, or when the stimulus becomes unbearable, that you now see a cell injury. So the cells can go from hypertrophy, the tissue can go from hypertrophy, hyperplasia, atrophy, even metaplasia. So it plays around with all these methods and several other mechanisms to be able to adapt to the foreign stimulus, so that and in many cases the body does a very great job, is able to withstand this pressure through these various means. But when the stimulus is so severe, that is where irreversible injury sets in and damage arises. So that is the end of this section, and I hope you are able to understand it. But the key concept is this: in cellular adaptations to stress, hypertrophy, get this right, is increased cell and organ size, often in response to increased workload induced by growth factors produced in response to mechanical stress or other stimuli. It occurs in tissues that are incapable of cell division. That is hypertrophy, while hyperplasia refers to the increased cell numbers in response to hormones and other growth factors. It occurs in tissues whose cells are able to divide or contain abundant tissue stem cells. Okay, that is hyperplasia. While atrophy refers to decreased cell and organ size as a result of decreased nutrient supply or disuse. It is associated with decreased synthesis of cellular building blocks and increased breakdown of cellular organelles. While the last one, which is metaplasia, refers to change in phenotype of differentiated cells, often in response to chronic irritation that makes cells better able to withstand the stress, usually induced by altered differentiation pathway of tissue stem cells, may result in reduced functions or increased propensity for malignant transformation. So that is those are the issues that I want you to take cognizance of, and I hope you've enjoyed this. So I also want you to read more about how reversible injury arises and how an injury becomes irreversible. So we have all of these in the material that we are using. So read these sections, and you'll be fine now. Thank you. Marty.